We are now feeling familiar with the training, train, test, split, and computing model performance metrics on our test set. But there is a potential pitfall of this process, and cross-validation motivation. If we are computing R squared on our test set, the R squared return is dependent on the way that we split up the data. The data points in the test set may have some peculiarities. That means the R squared computed on it is not representative of the model's ability to generalize the to unseen data. To combat this dependency on what is essential on a random split, we use a technique called cross-validation. We begin by splitting the data. We begin by splitting the data set into five groups of five groups or folds. Then a first set, yeah, first set. Then we set aside the first fold as a test set. This is the test set, and and fit our model on the remaining four folds predict on our test set. And fit our model on the remaining four folds predict on our test set. Compute the metric interest as R squared. Next, fit on the remaining data predict on the test set. Next, and compute the matrix interest again. And same thing, the similarity with the third folder and fourth folder. The fifth fold, as a result, we get five values of R squared, from which we can compute statistics of interest, such as the mean, median, and 95 confidence intervals. So, as we split the dataset into five folds, we call this process five-fold cross-validation. If we use 10-fold, it is called 10-fold cross-validation. More generally, if we use k-fold, it is called k-fold cross-validation or k-fold CV. There is, however, a trade-off. Using more folds is more computationally expensive. This is because we are fitting and predicting more times. To perform the cross-validation in scikit-learn, first we will import from sklearn.model selection underscore model dot selection import cross underscore val underscore square comma k-fold. Here k-fold, where we also import k-fold here, which allows us to set the seed and shuffle our data, making our result repeatable downstream. So we first call k-fold, and that then we use the n underscore split, where default is 5, but in this case we use the 6. Shuffle, allowing us to use the six folds from our data set for the cross validation. We use the shuffle to true, which shuffles our data set before splitting into folds. And we also assign a seed to the random underscore state keyword argument, ensuring our data should be split in the same way. If we repeat the process, we say, making the result repeatable downstream. We save this as the variable kf. We then call the cross underscore val underscore score passing the model. The feature data and a target variable, target data as the first third position arguments. We also specify the number of folds by setting the keyword argument CV equals CV results. So CV equals to our k-fold variable. This returns an array of cross-validation scores which we assign to CV underscore results. Note that the score reported is R squared, as this is the default score for the linear regression. So evaluating cross-validation performance. Here we can now print the scores. This returns the 6 results ranging from 0.7 to approximately 0.75. We can calculate the mean score using the np.mean and the standard deviation using the np.std. Additionally, we can calculate the 95 confidence interval using the np.quantile function, passing our results followed by a list containing the upper and lower limits of our interval as a dimensional decimals. So let's practice. So I will create a one notepad. This is my Jupyter notebook. This is my Jupyter notebook. Where I need to first, as usual, first I need to import the statements, now pandas and numpy. Then data. I need to import the data frame. This is the data frame. This is the data, and also first I'm taking only I'm dropping the TV, sales, and influencer. So I'm taking only radio and social media. Print the shape of that. This is the shape of X, and print shape of SHA, shape of Y. This is the shape of Y. First 5 values of X. This is the first value, 5 values, and also first five values of, this is the numpy array. So first 5 values of target variable. So first I'm importing the k-fold cross validation. This is the I'm taking as the kf. So then we are using the regression. So for that, what we need to do, we need to here. So first we need to use the regression equation. So in order to do that, what I need to do, I need to first I need to import the regression equation. To import the regression equation, we need to use linear regression. So I'm using the linear regression. Then again, I'm using the object for linear regression. This is the linear regression object. Then this is the k-fold. If I print the k-fold, these are the k-fold values. These are what we call what is this R squared for the each fold range from between 0.74 to 0.77. 0.77. This is the range values. These are R squared for each fold range from between 0.74 and 0.77. By using cross validation, we can see how the performance varies depending on how the data is split. So that is where, and also I'm printing the what you call mean and standard deviation. These are the standard deviation values, and also uh, conversion intervals, where this is the confidence intervals. Yeah, we calculated, we use the cross validation. This is where we are evaluating the model performance using the K-fold. I hope you understood. Thank you.